So hello, hi dear students. So welcome to the JK Easy Physics channel, YouTube channel. So let's see the JEE main exam. So January 2026. So that is morning shift exam is here. Okay, so you have to solve the JEE main examination MCQ questions. So let's see first question. What is the question? Potential energy versus distance. So this is a potential energy, this is a distance. So this is the graph. What you have to calculate? So you have to calculate magnitude of force. So what is the relation between magnitude of force and potential energy versus distance? So this is the relation, that is minus dv by what? Dx. So mod of this one magnitude is here, that is equal to dv by what? Dx. So dv means what? Which axis is? This is y axis, this one is x axis. So y axis by x axis means what? Slope. So now you have to calculate slope. First one, that is FAB is equal to what? VB minus VA divided by XB minus XA. So that is, VB 1, so 1 minus 0, 1 minus 0 divided by, this is 1 minus 0. So we get the answer is 1. Second one, FBC. FBC. So that is VC 4 minus 1 divided by what? 2 minus 1. So that is equal to answer 3. So like that you have to solve it. We get the answer, that is FBC, then FAB, then FDA, then FCD. So which is the correct answer? Okay, let's see. Fourth option is here. So this is fourth option. So this is the right answer. Fourth option is the right answer for this question. Next, move to the next question. Second question. A gas is based on the geyser. So this is a gas geyser. So water is flowing at the rate of, so that is volume of the water flow 5 liter per minute. So 5 liter means it is 5 liter per minute, can be converted into second. So that is 1 divided by 12 liter per second. So temperature, that is change in temperature, is equal to 87 minus 27. So that is the answer is what? So 27, 80, 40 degree Celsius. So heat combustion. So heat combustion is equal to 5. Specific heat capacity of water. So that is specific heat capacity of water is equal to 4200 joule per kg per degree Celsius. So now the rate of combustion. So the rate of the combustion of the gas you have to ask is here. So how to solve this one? First you have to calculate how much heat is required. Okay, how much heat energy. So how much heat energy it is requirement, that is a specific heat capacity is equal to, formula is delta Q divided by M into delta T. So that is delta Q is equal to SM delta T. So then how much heat is required? So that is the specific heat capacity 4200 into m, mass. So mass per second is how much? That is 1 by 12 into 40 into 40. So that is, we get the answer. Sorry, this is a 60 is here. So this is 60. So into 60, 12 1 ja 12 5 ja. So we get the answer. So 21,000. 21,000. So now that is one more given data is here, heat combustion of the gas. So let x be the what? So let x be the combustion of the gas. Okay, let x be the consumption of the gas. So now that is x into 5 into 10 to the power of 4 is equal to 21,000. So x is equal to answer 0.42. This is the answer for this question. That is option 3rd is the right answer. So what is the question 28? A conducting circular loop of area 1 meter square placed perpendicular to the magnetic field, which varies with this one is magnetic field. So now this is a conducting circular coil. So this coil is placed perpendicular to the what? Magnetic field is here. So that's magnetic field value is how much? So that is sine 100 t. If the resistance of the loop is equal to 100 ohm, so area is how much? 1 meter square. If the resistance of the loop is 100 ohm, then average thermal energy dissipated in the loop of one time period is. So that is thermal energy is dissipated. The question is asked thermal energy dissipated in the loop. So how to calculate of this one? So that is thermal energy dissipated in the loop is equal to in one time period. So one time period means 0 to 2 P into dt. So this is the formula is here. So now how to calculate P and how to calculate T. So this is a format is what? So the format is sine omega t. Omega is how much? 100. So what is the relation between omega and t? Omega is equal to 2 pi by t. T is equal to 2 pi by omega. So that is 2 pi by omega is 150. So that is time period is equal to pi by 50. So now it is solved it. Then P. So P is equal to what is the formula is here? That is a P is equal to V square divided by R. So that is EMF square divided by R. So now, but what is EMF is here? EMF is equal to minus N into d pi b what? dt. So conducting circular loop, N is how much? 1. So now how to calculate the magnetic flux is here? So that is magnetic flux is equal to number of magnetic field lines passing through the area. So that is sine 100 t into area is 1. So then EMF is equal to, so d pi b what? dt. So what is the differentiation of sine 100 t? The differentiation of sine is what? Cos 100 t into differentiation of 100 t is what? 100. So now this is the value of EMF. So that is EMF is equal to 100 cos 100 t. Okay, so now P, how to calculate P? So P is equal to, so this one is formula is here, so that is 10 to the power of 4 cos square 100 t divided by resistance is 10 square. So we get the answer is 100 cos square 100 t. So this is the value of P. P is equal to 10 square cos square 100 t. So now put this value on equation 1. So then equation 1 becomes, so equation number 1 becomes, so that is thermal energy dissipated is equal to 0 to pi by 50 100 cos square 100 t. So now this is integration, so converting this integration square into, okay, by using this one formula, converted to the simple formula, that is cos square theta is equal to 1 plus cos 2 theta divided by 2. So this is the formula. So now that is integration of pi by 50 1 plus cos 200 t divided by 2. So now after the simplification we get the answer is what? Pi. That is option 3 is the right answer for this question.